Well, thank you for the introduction, Jesse. Obviously, my name is Michael. I am a rising senior at Marin Academy, and my project is a solar panel basically that I designed to track the sun with the daily movements. So I chose this project because I wanted to learn more about coding and the electrical engineering aspects of designing sustainable energy systems. So I'm going to go ahead and share my screen here. This is basically a video of the actual full chassis and solar panel. So looking at this picture here, you can see the main components. So that small little board with those flashing lights is the Arduino controller. So that's the heart of the whole operation, which is wired up to this breadboard right next to it, this white sort of piece of machinery. And then we have, for the second component, the power circuit on the left side. You can see those three sort of things bunched together. And then in the center, we have the main chassis and the solar panel with the light sensors coming off the top of it. So going into how it works, you can see here, as one side of the solar panel receives more light than the other side, it starts to adjust the panel until both sides are receiving the same amount of light. So therefore, if the sun was shining more on one side of the solar panel than the other, it would readjust its position until the sun is covering the entire solar panel, so it reaches maximum efficiency. So this is a quick little picture of my code. So if you look towards the bottom, it's these two if statements of when one value of the light sensor is greater than the second value of the light sensor, it tells the servo to turn in increments of 15 degrees until both the values are at the same, or both the values are the same. So moving on to the light, or the circuit for the power, I was forced to add a full power circuit because the solar panel is rated at 3.3 volts. And a phone, for example, charges at 5 volts. So I have a DC input running into the power booster here. And in the power booster, I attach a capacitor to regulate the flow. But what this power booster does is it inputs the 3.3 volts into the booster through the battery and then out as 5 volts into the USB connector. So in terms of modifications, I aim to add two main modifications, including hydroelectric and wind power. This is an example of a hydroelectric generator, which I plan to add. But my main modification is a buoyant chassis, which I'm going to mount the solar panel on, alongside the hydroelectric and wind power to try to make a more efficient sort of boat or ship, and explore the effects of multiplying efficient technologies like hydroelectric, wind, and solar power. I was faced with multiple challenges, especially with 3D printing. I have a couple of examples here of all the different iterations I had to go through and how it's very tedious when you print it out and it barely doesn't fit. It's an entire piece, but it doesn't fit the actual thing by a millimeter. So now you have to do the entire thing over again. So that was definitely a tedious process, but it was a very good learning experience. But yeah, I really learned a lot about electrical engineering and coding, which was my goal. And I really enjoyed diving right into the Arduino and the electrical part and learning about all the different combinations of software and hardware that you can do and make via the Arduino interface. So I learned about, or what I mainly learned about the various processes of engineering is that for my system to function, for example, it needed the software to instruct it, the Arduino and the light sensors to inform it, the servo and the chassis to physically execute the movements, and then the power circuit to store its output. So therefore, I would definitely say the main lesson that I learned from this process of engineering was the understanding that my solar panel sun tracker is not any of these sections alone, but the amalgamation of all these sections together, and that each section has a part to play for it to function as a whole. So therefore, the engineering process can be quite tedious, especially if one part renders the whole dysfunctional. However, I learned that firsthand that this process is all about making parts into a whole that functions as one. Does anyone have any questions?
Yeah, I had a question. So I guess since I was your instructor, I know a little bit more than some of the other people. But do you want to talk a little bit more about some of the kind of ideas you had for that flow system to generate power through the hydroelectric generator on your boat?
Mhm. So the main idea behind this design is that a boat is already being propelled through a body of water. And what a hydroelectric generator does is it intakes the water and then it turns this turbine, which turns the generator and then outputs the water. So if you were to mount these on the hull of a boat, like 2 to 6 of them, then as the boat's already moving through the water, it's also generating electricity. So therefore, this would extend the battery life and the distance that a boat could achieve by just the hydroelectric aspect. So if you add a solar panel to the top, and the reason I wanted it to be a sun tracking one is because that provides the most efficiency. And then wind generators on the above water part of the hull, then you can do the same thing, but basically with 3 times more efficiency.
So is your goal to achieve a system of combined solar, wind, and hydro to provide continuous energy for your boat?
Yes.
It's very admirable.
That's definitely the base of the system.